Hello, George. Today's lesson will be an introduction to fractions. Is that something you feel confident about?
I probably need a refresher, but I used to be able to add and subtract fractions. Can I ask you a question, Gus?
Well, yes, George, if it's relevant to maths.
Well, it's about maths, Gus. When you talk to other maths teachers, do you always talk about numbers? Or do you even talk in numbers?
Well, George, we all do have a life outside of maths, and no, it would be a bit silly to talk in numbers, although I suppose it would be possible, as every letter of the alphabet has a numeric code in decimal or binary or hex.
Hex? What the heck is that? How would you say hello in hex?
Well, to say hello, I would say 48, 65, 6E, 6E, 6F.
Well, I think I'd just prefer to say hello, wouldn't you, Gus? It would take me a day and a half to say a sentence, and the other person would probably think I'm bonkers.
Well, yes, George, hex codes weren't really invented for spoken language. Maths is a subject for expressing logic, so I think it's time to look at fractions on the blackboard and see how well you understand them. Okay, so today we're going to be looking at adding fractions, and I'm joined here by George, who I'm sure will be giving me some suitable responses to questions that I'll be asking him on the way. And beside the problem and fractions, we have a circle. The circle is there to help us to visually represent how we add fractions together. So we can think of the circle as perhaps representing a pizza. I should be cutting that up into pieces in a moment. Do you like pizza, George?
Yes, I do, but I would need a very good imagination to think of that as a pizza. It's all black in the middle.
Okay, George, don't be so pedantic. Let's get on with adding together fractions. Now, if you knew nothing about fractions, George, and I asked you to add those together, you did know how to add numbers together, what kind of answer would you come up with?
Well, I would add the two numbers at the top together, and that would give me 4. And then I would add the two numbers at the bottom together, and that would give me 12. So my answer would be 4 over 12.
Okay, George, well, of course that is not the right answer, but it is a common mistake that a lot of people make when they first start fractions. Although it says add between the two fractions, it doesn't mean you add the two top numbers together and the two bottom numbers together. Fractions don't behave like whole numbers in that sense. And this is where we're going to have a visual representation of the fraction. So let's go over to the circle. Okay, so the circle represents the whole pizza. So how do we represent the fraction 3/4 from the circle? Well, the bottom number in a fraction represents the number of parts we're going to divide the circle into, and the top number, the 3, represents the number of parts that we want out of that pizza. So we want to divide the pizza into 4 pieces, and we want 3 of those pieces. So you can see that I have divided the circle up into 4 pieces, and now I want to take 3 of those pieces. So as well as the 3/4, I also want an 1/8. Now, to represent the 1/8 on the circle, I would need to divide the circle into 8 pieces and remove one of those pieces. So what I'm going to do now is I'm going to draw some more lines on the circle so that it's divided up into 8 equal pieces. So now you can see that there are 8 equal pieces in the circle. The 3/4 is still represented by the green part of the circle. And now we need to represent the 1/8. So I just need one of those 8 pieces. So I'm going to put that in a different colour. Okay, and there is my 1/8. Okay, George, so could you tell me please what you think the answer to the question is? What is 3/4 plus an 1/8? How many pieces or what fraction of that circle is coloured?
Well, there are 8 pieces altogether, and 7 of them are coloured. So the answer must be 7 over 8.
Okay, well done, George. That's exactly it. The answer is 7/8. And I'll just write the answer on the line below. Okay, so how could we have done it without using the circle itself? Well, we need to know a little bit about equivalent fractions. If you look at the circle, the 3/4 is the green part of the circle, but we could also think of the 3/4 as being 6/8. Because the circle has now been divided into 8 pieces, and 6 of those pieces are green. So the 3/4 and the 6/8 must be exactly the same as each other. The 1/8 is the second fraction. I haven't changed that one. So if I look at it as being 6/8 plus 1/8, then it becomes a little bit more easy to see where the answer comes from. The 8 at the bottom hasn't changed at all in the answer, and it's just the two top numbers that we've added together. So what we need to learn about fractions is that we can only really add them together when the numbers at the bottom are the same. Because when the numbers at the bottom are the same, then we're talking about the same size of slice, and therefore we can add the numbers together on the top. So the question now arises as to how we would do it arithmetically, because we don't want to have to go to the trouble of drawing circles every time we're doing fractions. Well, we need to examine the original fraction, which was 3/4, and its new form, which is 6/8. Now, if you look at the numbers on the bottom first of all, the 4 has been changed into 8, and in order to do that we would have multiplied it by 2, but the same thing has happened to the number at the top. So when you're changing fractions, whatever you do to the bottom you must also do to the top. So we just multiplied each of them by 2. So when you're adding fractions together, you do need to make the two bottom numbers the same, but you will have to look at what you've got at the bottom in order to work out how to do that. In this case, it's fairly simple, because in order to make 4 the same as 8, we need to double it, and that's exactly what we've done down here. But we've also obviously doubled the top as well as the bottom. Okay, George, so do you think you understood that work on fractions?
Yes, I understood the fractions, but I still don't like the pizza. And by the way, what would you do if there was a 3 and a 5 at the bottom?
Well, that's a very good question, George. If there was a 3 and 5 at the bottom of each fraction, then we would have to change both of them, and we would have to change them to 15, as 15 is in both the 3 and 5 times tables. Maybe that's something that we'll look at in our next lesson on fractions. But I am sorry you didn't like the pizza, George. Perhaps I need to improve on the toppings next time to make it more appealing to you. And so that's the end of the lesson now, and it's goodbye from me.
It's goodbye from me.